This is the world's first 102 terabit per second silicon. Enterprise Sonic will be supported very soon on this silicon. This is Tomahawk Ultra, is a myth buster silicon. Is the fastest Ethernet silicon in the world.
Oh, wow. Hello guys, my name is Lucas and today I am with my friend Kamran from Broadcom and we have something exciting to share with you. In our hands we have the latest generation of the Broadcom Tomahawk6 and we can tell you with the help of my colleague a little bit more about the use case and why it is really something unbelievable in our hands.
Sure. So Tomahawk 6 is a revolutionary product in the sense that this is the world's first 102 terabit per second silicon. So this is the first time we have seen that we have been able to break the barrier of 100 terabit. So this silicon has 1,000 100 gig SerDes,
Wow.
right, in this form factor.
So where do you see a use case for such as this?
So this was specifically designed keeping in mind the AI environments, the scale-out network for AI infrastructure. But what we have seen is more recently, there are a number of vendors out there who want to utilize this chip in their scale-up networking as well. So this is becoming a very versatile chip, suitable for scale-out as well as scale-up networking.
And speaking about the vendors and the hardware, we already saw guys like the EdgeCore, Celestica, Eufy coming with some first designs with 64 times 1.6 tera.
Yes.
This is just unbelievable.
Yeah.
Even 128 times 800G, which
Exactly.
is also really impressive. I know that the Tomahawk's been always designed to be, let's say, fast, and if I can say a little bit dummy, but I saw that from the Tomahawk 5 it was changing. You've been adding VXLAN support and so on. So how that feature enrichment is going?
Exactly. I mean, this is the amazing thing about technology, right? We've been improving and improving. So not only that this silicon has a lot of bandwidth, it is also feature packed. So this is a silicon which introduces the second generation of what we call the cognitive routing characteristics. So this is an umbrella term that we use for a set of capabilities which make the silicon very suitable for AI environment. AI traffic is very different. If we try to use our traditional models of networking in an AI infrastructure, networking becomes a bottleneck. So we are packing these silicon with specific capabilities like global load balancing, right, like DLB. So these silicon can meet the requirements of today's AI infrastructure.
Perfect. And guys, as you know, we are specializing and focusing on the Sonic, Enterprise Sonic. So I hope that soon we will see a lot of porting with that new beast.
Oh, absolutely, yeah. Enterprise Sonic will be supported very soon on this silicon.
Perfect. So speaking about that one, so what is the difference between the size?
So they look different because they have different size. But this is Tomahawk Ultra. This is what I call is a myth buster silicon. Let's face it, there has been a lot of myths about Ethernet, that Ethernet is, for example, not suitable for HPC environment with ultra low latency. Wrong. There has been a myth about Ethernet that Ethernet cannot support a large amount of small number packets with small sizes. Wrong, right? What I'm holding in my hand is what I call is the fastest Ethernet silicon in the world.
Oh, wow.
In the sense that the fall through latency of this silicon is under 250 nanosecond.
Unbelievable.
Right? So this is the fastest Ethernet silicon we have seen in the world.
So again, the use case.
Yeah. So this is used for specifically designed for two use cases. Number one, this is used for the HPC ultra low latency applications. There are certain applications. I mean, this silicon will work in most HPC environments.
Yeah.
Tomahawk 6, right? But there are certain HPC applications which require ultra low latency. And for those applications, this is the silicon below 250 nanosecond latency.
So we will expect to see it in just like a typical switch design or not only?
Not only that, because the second use case this has is for scale-up networking.
Okay.
Right? So within a scale-up network, when you use this type of chip, you may be using it within a rack design. So you have a rack full of AI servers, and the scale-up connectivity, the connectivity of your AI servers within the rack is using this Tomahawk Ultra silicon. The other good thing about this silicon, I'll mention two characteristics very quickly, is that this can stream a very high amount of small packets.
Okay.
Right?
Which
So
is
this can
totally
do-
different story
which
with
is different from this, yeah?
LF flow, yeah?
From any other Ethernet chip, right?
Okay.
So this can have a line rate of 64 byte packets going through it, which gives it a 77 billion packet per second capacity. So it's got a very, very strong engine, which works very well with the small packet, and that is something we need for our ultra low latency HPC application. Also, this is something we need for our scale-up networking.
So how your team been able to, really manage that ultra low latency in the design? What is special if you are comparing it, yeah?
So this is, if one thing that is probably obvious to your viewer is that you will probably, if you zoom in, you will see this is a multi-chip design, this is a single-chip design, yeah. And also, we have to really think out of the box. We have to make a lot of architectural change to allow this ultra low 250 nanosecond and this very high small packet rate that we support on it. And the last thing that I mentioned about this one is that for your scale-up environment, if your switches can do some in-network computing, that makes your scale-up network very optimized. And Tomahawk Ultra has a built-in INC engine, in-network compute engine, which can do a lot of collective operations for your scale-up networking. So this can really optimize your rack scale networks, rack scale solutions with this capability.
And how about, the availability? I know that one is simply GA. We see slowly even the hardware, the guys been just been using it. But how about the Ultra one?
So this one is a little bit more specialized, right?
Yeah.
So this one is being used at the moment by some of our hyperscaler customers for their scale-up requirement. There are also some of the vendors, I can't name them at the moment, who are building supercomputers, and they are using it for their rack scale systems. You will be seeing those solutions in the second half of 2026.
Okay.
But also there are some other mainstream OEMs, ODMs who are making switches based on Tomahawk Ultra.
Just switches with ultra low latency.
Correct.
Just simply like that, yeah?
Correct.
So really appreciate for your time and all the explanation. We are today on the CLOUDFEST, but more or less after next month, we are going on the OCP, and I hope that we will see you there again.
Absolutely. See you at OCP EMEA in Barcelona.
See you for sure. Thank you. Thank you.
Cheers.
Cheers.